Today, lesson 39C, solving exponential equations. We've been working a lot lately on simplifying expressions that have exponents in them, and we've worked on a little bit on the equivalency of exponential expressions. But there are times where we may have an equation that has a variable as an exponent. We typically refer to those as exponential equations. And today, we're going to talk about how to solve those types of things. So let's go ahead and get started. As we all know, from 6th grade, when you first started talking about exponents, then we had something like an expression like 3 to the 4th power, that the 3 was what we refer to as the base, and the 4 is the exponent. All of you are very good at these types of things now. And that, of course, means that we're going to write down 3 4 times and then find the product of those 4 3's, which, of course, is 81. So if we take that idea and kind of turn it into an equation where we have something like 3 to the x power equals 81. Well, we already know that x has to be 4 from the previous problem. But while this one is easy, some of the problems that we're going to be doing are not quite as easy. So I want to take a very easy problem and sort of go through the process of what we should be doing in the majority of these problems. So what we want to do is we want to figure out what x is, which once again we know is 4, but it's easiest in these types of problems if we convert both sides of the equation to a like base. In other words, make them so that they have the same base if that is possible. And in this problem, it is possible because we know that 81 is 3 to the 4th power. And then once we have a like base, then what we're really looking at is we're looking at this part of the problem right there. Let me change pen colors here. So we're looking at this part and this part and this part right there. And we can see from that that x is equal to 4. Okay? So let's, first of all, look at the property that allows us to do this. So there's a property with dealing with exponents that says that if a to the x power is equal to a to the y power, notice that the bases are the same, then x has to be equal to y. And it is that idea that allows us to do what we're doing. So once you have common bases, you may set the exponents equal to each other like I just did in that problem. Okay, so let's take a look at number 1. 2 to the x power is equal to 1 over 32. Well, the left-hand side has a base of 2, so the first question might be, well, how can I turn 1 over 32 into 2 to some power? So I want you to think about that for a second. And so what we have to do, we know what power of 2, or we can easily figure out what power of 2 is 32, but 1 over 32 is the reciprocal of that, so that should bring back some ideas of negative exponents. So 2 to the 5th is 32, whereas 2 to the negative 5 is equal to 1 over 32. So all we are doing here is we are replacing 1 over 32 with 2 to the negative 5 because they are equivalent to each other. And then once we do that, we now have that common base, which is what we have to deal with. And so some of you, it may take you a little bit longer because of the fact that you have to think a little bit about what sort of equivalency we're going to need or use, but we're just tossing around ideas that we've done over and over and over again. Like, for example, if I had given you this earlier, a week or two ago, you would have known that that's 1 over 32. So we're just thinking about ideas of equivalency here. So now, we have our common base, so x has to be equal to 5. And that is what it is. So x is equal to 5. All right, let's take a look at number 2. And I'll give you a minute or two to try and figure that one out. All right, so let's take a look at number 2. On the left-hand side, we have a base of 5. On the right-hand side, we do not have a base of 5. We have 125. But we can easily turn 125 into an expression with a base of 5. And that is because that 125 is equivalent to 5 to the third power. So once again, all we did, these two are equivalent to each other, so it's okay to do that. Now, once we have that, we have our common bases here. So now we can set up our equation that sets the exponents equal to each other. So 2x is equal to 3. Taking this easy one-step equation from 6th grade, we can see that x has to be equal to 3 halves. Now, if we wanted to check that, we could easily check that by substituting 3 halves in here for x. And then we do a little bit of simplifying. On the left-hand side, we have 5 to the third, and so we do know from doing many problems like this one that 5 to the third is equal to 125. All right, and once again, we're utilizing that property right there. All right, everybody try number 3. All right, so there are times where it is difficult to turn one side into the same base as the other side, like in this problem. However, we can turn them or change both of the bases into a common base. So for example, 9 is equal to 3 squared, and 27 is equal to 3 cubed. Now, what I did here, once again, is I'm replacing 9 with 3 squared because they are equivalent to each other, and 27 with 3 cubed. Now we have to think back to the power to a power rule, because we've got a power to a power right there. But essentially what we're doing is setting these two exponents equal to each other. So now we have 4x minus 10 is equal to 3. We add 10 to both sides, and then divide both sides by 4. And we get x is equal to 13/4. And I could substitute that back in to show you that they are equivalent, but they are. And so we end up, once again, with 13/4. Let's keep going here. Everybody try number 4. Now we're going to take a look at number 4 a couple of different ways. So on the left-hand side, we have a base of 4. On the right, on the left-hand side, we have a base of 64. On the right-hand side, we have a base of 4. And I could turn 64 into an expression with a base of 4, and that is the fact that 64 is 4 cubed. So we have 4 cubed to the x over 3 power is equal to 4, and remember that is really 4 to the first power. Now we have the same base. We could do an exponent or a power to a power there and multiply our exponents, which would give us 4 to the x power, because 3 times x over 3 is, I could do that off to the side if I don't see it, but 3 times x over 3 is x, and so we have 4 to the x equals 4 to the first, and so x is equal to 1. Now that is not the only way of doing that problem, because maybe you looked at it like we did in the previous problem, and maybe you thought that, well, I want to turn them both into a base of 2. Well, 64 is 2 to the 6th power, and 4 is 2 to the 2nd power. So taking our power to a power again, we have 2 to the 2x equals 2 to the 2nd, and then taking our exponents and setting them equal to each other, we still get x is 1. So in some of these problems, there will be more than one way of dealing with them. Okay? And I'm going to do this one with a base of 4. All right, everybody try number 5. And so in all of these problems, you need to think about what that common base is. And in number 5, the common base is 2. It's not 4, because you can't, well, you could, but it's very difficult to turn 32 into a power of 4. So let's use 2. So 1/4 is 2 to the negative 2 power. Once again, that is equivalent to that. And 32 is equivalent to 2 to the 5th power. And now, like in some of the previous ones, we have a power to a power. So we have negative 2 and 5x. And so we multiply exponents when we have a power to a power. And so now, using the property of exponential equations, we can set the exponents equal to each other because of the fact that the bases are the same. And so x is equal to negative 1/2. And once again, that comes from the fact that we have negative 10x equal to 5. And when we solve that, kind of out of room here, but we get x to the negative 1/2 power. So the key here is making sure you have a common base. Everybody try number 6. All right, common base in number 6 is 5 because I can turn 25 into 5 squared. So we have 5 squared to the 2x minus 1. And I can turn 125 into 5 cubed, so that's 5 cubed to the 3x plus 4. Now what's different about this problem is we have a power to a power, and we have a power to a power. So 3 times the quantity of 3x plus 4 is 9x plus 12. And in both of these situations, that comes from the fact that you have this in terms of the power to a power on the left side, which gave us this right here. And on the right-hand side, we had a power of 3 and a power of 3x plus 4. I've forgotten the 3 there. And when you distribute that, you get that right there. Now that we have our common base, we can now set the exponents equal to each other. And for the first time, we have an equation with variables on both sides. But this is one of the reasons why we have been working on that kind of stuff. So I like to get the variables on the left-hand side, so I'll work with that first by subtracting 9x from both sides. Now we have a 2-step equation, so add 2 to both sides. And we have a lot of these, as you can clearly see. They don't come out even. But that does not matter. We can see that x is negative 14/5. So same idea, but the difference here is that we have variables on both sides of the equation after we get our common base. Okay, so once again, common base is 5. Use the power to a power rule to simplify the exponents. Now that we have our common base, we can set the exponents equal to each other, and we get x equals negative 14/5. All right, everybody try number 7. Just like the previous 6 problems, we have to get a common base. The common base here is 2. We can replace the base of 8 with 2 to the 3rd. We can replace the base of 1/16 with 2 to the negative 4 power. Now we take our power to a power. 3 times the quantity of 2x minus 3 is 6x minus 9. Negative 4 times the quantity of x minus 2. You have to be careful there. That's 9 and negative 4x plus 8, not minus 8. And now that we have common base, we can set these two things equal to each other. And at this point, you guys have done enough of those types of equations. Add 4x to both sides, which gives us 10x on that side. Add 9 to both sides. That gives us 17 on the right-hand side. And so x is 17/10, or equivalent versions of that. Okay? All right, let's keep going. Number 8. Everybody try number 8. Common base in number 8 is 3. So we will replace 9 with 3 squared and 1/27 with 3 to the negative 3. We have a power to a power again. So on the left, 2 times the quantity of 2x plus 3 is 4x plus 6. On the right, negative 3 times the quantity of 3x plus 1 is negative 9x minus 3. We have our common base. We set the exponents equal to each other and solve, and we get x equals negative 9/13. Last problem. Go ahead and try it. All right, common base in number 9 is 2. We'll replace 4 with 2 squared and 8 with 2 cubed. We have a power to a power. Now that we have our common base, we can set the exponents equal to each other and solve, and we get x equals 19/6. And that is it for today.